In this project, we will create a pan tilt assembly control. This is a handy accessory that can be included on your car projects or robots and can be used to mount a camera. The direction that the camera is pointing in can be adjusted and fully controlled with the pan tilt swivel mounting. We will be using a Wii Nunchuk to control our pan tilt assembly in conjunction with two servos and a pan tilt frame. This is a really cool project and will bring together the concepts we learned in our previous two lessons. Let's get going. I can't wait. Now for the objectives. By successfully completing this project, we will have mastered the following items. You will understand how the Wii Nunchuk can be used in conjunction with servos to control our pan tilt assembly. You will get a good grasp on how positional readings taken from our Nunchuk can be used to control the servo motors. If you are ready to begin, let's get this project started. Here are the parts we will need: an Arduino Uno, a USB cable, a breadboard, two mini servos, a Wii Nunchuk, the Arduino Nunchuk adapter, the pan tilt swivel assembly, and connecting wires. Let's take a look at the circuit diagram. To make it easier to wire up the diagram, I've created a few cheat sheets on the right of the circuit diagram. For our Nunchuk, we have seen this wiring before, it remains the same. And for our servos, servo 1, the signal pin is connected to pin 9 on the Arduino, and for servo 2, the signal pin is connected to pin 10 on the Arduino. The ground and power pins would be connected to ground and 5 volts respectively. Okay, let's go ahead and wire up our circuit for our pan tilt assembly with our Nunchuk. So we'll wire up the connections for the Nunchuk first. Let's connect the ground on the Arduino to the ground rail on the breadboard. Next, we'll also connect the 5 volts on the Arduino to the 5 volt rail. For the Nunchuk, we have the negative pin going to ground. The positive pin, remember, doesn't go to 5 volts, but it goes to the 3.3 volts pin. So we'll make that connection here. The data pin goes to pin A4 on the Arduino. And the clock pin from our Nunchuk adapter goes to pin A5 on your Arduino. Alright, so that completes the wiring for our Nunchuk. Next, for the servos, the bottom servo is going to be our servo 1, and that's going to be doing the panning. So for servo 1, we have the brown wire is our ground. The middle wire, or the red one, is our 5 volts. So that's going to go to 5 volts. And the signal wire is going to go to pin 9 on the Arduino. So we'll connect that. For our top servo, which is the actual tilt, that is going to be our servo 2 on our circuit diagram. So again, the ground pin is going to connect to ground. The middle pin is going to connect to 5 volts. And the signal pin is going to connect to pin 10 on the Arduino. Alright, so that completes our wiring. Now I'm going to upload the code for our pan tilt servo with the nunchuck. Alright, so we'll wait till that's complete. Okay, it's done. One thing we'll want to do is you'd want to set the servo up to initially to zero out the position of the servo. So right now when it initially starts up, it should be in the the 0 position, meaning the center. So I'm going to disconnect this actually and put this to face straight forward. Right about at the center. I want to make it as kind of straight as I can. About, and the top looks okay. So you just want to zero it out. Make sure that the bottom is facing straight forward and the top is about at the center. So now if I take my my nunchuck, and as you can see, if I tilt it left and right, that's the actual panning, and then the top, if I push it down and up, that's the pan tilt. So that's pretty cool. I am controlling, using the Wii nunchuck. I have a pan tilt servo and I could control. If I had a camera that was attached to the top here, maybe this was on a remote control car or robot, I would be able to control the direction that the camera was facing by using this sort of pan tilt mechanism. So pretty cool. So we have used the Wii nunchuck and we are using that to actually control this pan tilt swivel, and we're doing this is the actual panning motion left and right, and the top is the tilt. Pretty cool project, I would say, guys. I'm sure this will come in handy in lots of your projects. So let's take a look at the code for our pan tilt servo assembly with our nunchuck. So initially at the beginning we have 3 libraries that we include: the servo library, the wire library, and the Arduino nunchuck library. Next we define the baud rate and we create our servo objects. So we have myServo1 and myServo2. myServo1 will be the panning servo, and the myServo2 will be the actual tilting servo. Next we create the Arduino nunchuck object. So we instantiate that object calling the constructor, and we call that object nunchuck, and we initially have our position 1 as being 90 and position 2 as being 90. That means that when we first start off, our servos would be at the center. So remember, when you first wire it up and this program is first uploaded, you'd want to adjust your servos in the pan tilt brackets to make sure that they're facing, the panning one is facing straight forward at 90 degrees and the tilt is actually at 90 degrees, looking straight ahead. Next in the setup, we attach the pins to our servo objects. So servo 1 was the signal pin was pin 9, and servo 2 the signal pin was pin 10. We initialize our nunchuck, so we call nunchuck.init, and next we have we center the servos, so that's where we do a myServo1.right position 1, and that's initially 90 degrees, and the servo 2.right position 2, that's 90 degrees, and that should center everything up for us. In our loop function, basically we are getting the position and we do a mapping here for the actual panning. So we call the map function passing in nunchuck.analogx. That's going to give us the X position of our nunchuck joystick, and we are mapping that It goes from 212 to 24, and we're mapping that to a value between 0 and 180. 0 to 180 being the maximum range of our in degrees of our servo. So when the joystick is all the way to the left, that's going to be 212, and when it's all the way to the right, that's going to be 24. So we're mapping that to an equivalent value in the range of 0 to 180. Similarly, for our actual tilting, which is our servo 2, we pass in the nunchuck, that analog Y, that's going to give us the Y position of the joystick, and that ranges from about 38 to 220 when we look at the actual raw values, and we want to map that between 0 and 180. So when we calculate those positions in degrees based on the joystick position, we then do a right of position 1 to servo 1 and a right of position 2 to servo 2 with a short delay, and that causes the servos to move. So now the servos would be coordinated depending on how we move our joystick. I think this is pretty cool, guys. Just a really short amount of code, but it accomplishes quite a lot. And of course, we loop over in our loop function, and we continuously read the nunchuck and update the servos accordingly. Really great program, short and concise, but very powerful. Hope you guys enjoyed this one. To summarize, in this project, you learn how to control 2 servos on a pan tilt swivel assembly using positional readings taken from a Wii nunchuck. You were also introduced to the Arduino nunchuck adapter, which can be used to interface with the Wii nunchuck to help us communicate with the nunchuck using our Arduino. It was a great project, and we learned a lot of new concepts. This is a handy assembly that could be included in your robots or car projects and can be used to mount and control a camera. Let's check out our next project.